All right, 3.5, we're going to talk about inverse trig functions. And those words should give you great pause if you've been following along with the lecture series and understand that to talk about the inverse, your function has to be 1 to 1. So I want us to think about sine of x, and let's see why this is a problem. When you look at the graph of sine of x, here's just a really rough graph of the sine of x that I've sketched. And you can see it's majorly not 1 to 1. It like epically fails the vertical line test, actually infinitely many times. And so how can we talk about an inverse when the function is 1 to 1? Well, the point is you can't. But what we can do is we can actually restrict the domain of sine of x and shrink it down to make it 1 to 1. And so there's lots of ways that you can do this. So for example, we might restrict the domain from 0 out to pi. And the problem is we get this nice loop here, but it's not 1 to 1. It still fails the horizontal line test. And somehow we want to capture the full range. We want to capture that sine goes from -1 up to 1. And so the place to actually cut sine is from right here, the x value that gives you the low point, to the x value that gives you the high point. That gives you the full range, and you can see that part of sine is 1 to 1. And so what we're led to do is we're led to restrict sine, let's say y equals the sine of x, to, well, if you think about those x values, that was minus pi halves to pi halves. And please realize that the range is still -1 to 1. Okay, and so maybe we should actually sketch the graph of exactly what we're looking at here. So let's go ahead and do that. So let's see, something like, these are kind of hard to draw nice, but something like that. And then if you imagine the sine, it keeps going, right? That was a bit of a, yeah, there we go, something like that. So we're looking at the solid part, but you can see the dotted part there as well. And okay, so this x value is, of course, pi halves. This x value is minus pi halves. This y value is 1. This y value is -1. There it is. This function is 1 to 1. Hooray for us. That's so exciting. And so the point is, when we restrict sine to this interval, it is 1 to 1. Thus, it has an inverse. And now, how do we write this? Well, there's two ways to write it. Let's say it has an inverse denoted, and we can either write it sine -1 like that, and this is not 1 over sine. If you want to write 1 over sine, you would write sine of x all to the -1. So that would indicate the reciprocal, versus putting it there indicates the inverse. I admit that's not in some ways the best notation because it gets a little confusing, but with a little practice, it's not a big deal. Now, people have acknowledged that that's not ideal, the -1, and so another way that we refer to inverse sine is by writing arc sine. And so you should think of arc sine of x as the inverse sine function. That's exactly what it is. So this and this are the same thing. They're both the inverse of sine of x when you restrict to the interval minus pi halves to pi halves. All right, so in the next video, we'll go over some basic properties of inverse sine.